Welcome to the lecture. In this lecture, we will see some of the linear algebra operations in Python. So, first one is determinant of matrix, how to calculate rank, how to calculate the inverse of a matrix, and also how to solve the system of equations. So, let us get started. First, we will look at the determinant of matrix. To calculate the determinant of matrix, the matrix it should be a square matrix. So, it can be a 2 cross 2 or it can be a 3 cross 3 or it can be a 4 cross 4 matrix. So, the determinant of matrix is very useful in calculating the inverse and also it is used in solving system of equations. So, in Python, numpy.linalg.det it basically returns the determinant of the matrix. Let us say if I have a 2 cross 2 matrix A, B, C, D, A into D minus B, C. So, this is a way to calculate the determinant. So, if you have a 3 cross 3 also you can find the determinant, you can also do it for 4 cross 4 as well. The syntax is numpy.linalg.det and inside the parenthesis you have to specify the matrix. So, first we will create a matrix. I am going to create a 4 cross 4 matrix which means 4 rows and 4 columns. You can give values for the first row, that is 4, 5, 16, 7 and then after 7 you have to separate it with semicolon and again you have to specify the values for the second row and similarly for third row and fourth row. And here I am storing it in a variable called X matrix. Now let us print the matrix X. So, it has created a 4 cross 4 matrix which is a square matrix. Now, let us calculate determinant for this matrix. So, numpy. So, before calling the numpy you need to import numpy. So, you have to import numpy as np. np.linalg.det of x and I am storing in variable called det underscore matrix which is the determinant matrix. Now, let us print the det underscore matrix. The determinant value is 128.0. So, this is the value for the 4 cross 4 matrix. Similarly, you can create other matrix and you can calculate the determinant as well. Next one is rank of the matrix. So, basically the rank is used to find the number of linearly independent rows or linearly independent columns. So, in Python, so again in the numpy package we have the matrix underscore ranks which basically performs the rank. The syntax is numpy.linalg.matrix underscore rank and inside the parenthesis again you have to specify the matrix name which you are going to create. Now, let us consider the matrix X, same matrix. We will find the rank for this matrix. So, it is a 4 cross 4 matrix, right. For this 4 cross 4 matrix, calculate the rank. So, the command is np.linalg.matrix underscore rank and inside the parenthesis you have to specify the matrix name and I am storing it variable called rank underscore matrix. So, you can also store it in some other variable name as well. So, let us print the rank value. So, it shows 4. So, which means it has 4 linearly independent rows. Next, we will look at the inverse of a matrix. The inverse formula is A inverse is 1 by determinant A into adjoint of A. So, this is the formula for the inverse of matrix. So, in Python the command is dot inverse. It basically returns the multiplicative inverse of a matrix. The syntax is numpy.linalg.inverse that is INV and inside the parenthesis you have to specify the matrix name. I am creating a matrix 3 by 3 and I am storing in a variable in A. So, before calling np.matrix you have to import the numpy package, import numpy as np and from the numpy package you can call the matrix dot matrix. So, the values for the first row are 3, 1, 2, 3, 2, 5 for the second row and basically for the third row. So, now we have printed the values. So, this is a 3 cross 3 matrix. For this matrix, we will calculate the inverse. So, the command is np.linalg.in and inside the parenthesis I am specifying the matrix name which is A, and you can store it in the variable inv underscore matrix. So, now let us print the inverse of the matrix. So, this is the value for the matrix which we have created. So, this has written a inverse. So, it has calculated a 1 by determinant A into adjoint A and returns the output. Now, let us take another example for calculating the inverse. We will create another matrix B. So, this is again a 3 cross 3 matrix. Now, let us print the matrix B. So, the values are 2 1 2, 1 0 1, 3 1 3. So, it is a 3 by 3 matrix. Now, let us calculate the inverse. So, the command is np.linalg.inv and inside the parenthesis here I am specifying the matrix B. Now, let us print the value of the inverse. So, it has thrown us some error saying linalg error and it is a singular matrix. It is showing some error. So, we need to find what is that error, right. So, the singular matrix in sense the determinant will be 0. So, if the determinant is 0, inverse does not exist. So, we will not be able to find the inverse. So, let us look at the determinant for this matrix. So, np.linalg.det which is a command for the determinant and inside the parenthesis I am specifying the matrix B. So, now let us print the determinant value. The determinant value is 0 for in this case. So, if the determinant is 0, so the matrix will be a singular matrix. Condition to find the inverse is, so determinant should not be equal to 0. Now, let us look at the system of linear equations. So, if you have 2 or more linear equation, then it is called as a system of linear equations. So, if you solve 2 or more equations, you can get the unique solution or there might be a no solutions or there might be a infinitely many solutions. So, let us see how to do it in Python. So, we will consider a system of linear equations. So, in our case I have taken 3 equations which is 3x plus y plus 2z is equal to 2 and the second equation is 3x plus 2y plus 5z is equal to minus 1. Third equation is 6x plus 7y plus 8z is equal to 3. So, these are the 3 equations. So, we need to solve these 3 equations to find the value of the x, y, z. So, which are the basically the unknowns. So, we will write it in the form of Ax is equal to b. So, these are the 3 equations. Now, we will write it in Ax, coefficients for x is 3 and respectively the coefficient for y is 1 and respectively the coefficients for z is 2. So, that has been written in the first row which is the values are 3, 1, 2. Similarly, you have to write the coefficients for the x, y, z for the second row and similarly for the third row. So, A are the coefficient values and x, y, z are the unknowns and b are the constant values which is 2, minus 1 and 3. So, now we have written the equations in the format of Ax is equal to b. Now, we will solve. So, we will keep the x on this side and we will bring the A to on the other side. So, that becomes A inverse of B. So, we need to solve A inverse B. So, you can find the A inverse and then you can multiply with B or else there is a direct command which does the A inverse into B. So, in Python numpy.linalg.solve it basically written the solutions for the system of equations in the format of Ax is equal to B. The syntax is numpy.linalg.solve it basically solves the 2 matrices which is matrix A. You have to specify the matrix A and the matrix B. Now, let us create a matrix A and B. So, A is 3 cross 3 matrix. So, we will supply the values. So, after the end of each row you have to specify the semicolon. Similarly, you have to create a matrix B. In our case, so we had values 2, minus 1 and 3 which is along the columns which means you had 3 rows and 1 column. So, that is why we have used the transpose to create a matrix B. So, now let us will print the matrix A and B which we have created. So, the A matrix will be a 3 cross 3 matrix and the B matrix will be a 3 cross 1 matrix. So, the command is np.linalg.sol and inside the parenthesis you have to specify the matrix which you have created earlier. So, we have created a matrix and the B matrix and you can store it in a variable. Now, let us print the values. So, when you print sol underscore linear, so it has printed these 3 values. So, these are the values for the x, y and z. Let us summarize. So, first we saw how to calculate the determinant of matrix and we also saw how to calculate rank. So, rank it basically gives the number of linearly independent rows or columns and we also saw how to calculate the inverse. So, inverse formula is A inverse is equal to 1 by determinant A into adjoint A and then we also saw how to solve the system of equations. So, system of equations says Ax is equal to B. So, you have to keep the x on one side and you have to take the A on the other side. So, it becomes x is equal to A inverse B and then you can get the values for x, y and z. Thank you.